Hey there guys, how you doing? Today in this video we're going to be dealing with some applications of logarithmic properties. If you want, before you start this video, there is a printout or some notes so that you can write down that has these exact problems on it, or if you'd rather, you can use your own notes and just write down the problems and do that. It's not a big deal, either one. Also, I'll be having some help videos along with today's work. So if you're still wanting to see a couple more, I'll have those also separately attached. So go ahead and look down for those in the I need help section. Otherwise, let's get going. So we're looking at this first equation, which has an exponential value here that's missing. So we're assuming that the carbon-11 has an 11% or 100% present at time 0. We want to know what the half-life is. A lot of the questions that I've been getting from people with questions like this is like, how do I set up my equation? Luckily, it's already partially there, but like, what else do I need? Well, you should only have one variable, and I'm going to be solving for those. So that means that something should be in there in the y. If it's a half-life, I know that the starting value is 1,000. So the half-life is 500. And that's what your y value is going to be. So if I'm going to completely fill this out, I'd rewrite this as 500 is 1,000 equals 1,000.965 to the x. And another thing, the way I got that 0.965, if you're not sure, it's the same thing as writing 1 minus 3.5%, 0.035. Since it's a decay, I'll get less than 1. And then I'll go from there. So now we have to go through the process of solving, which now if we just look at something like this, taking away all the applicability of our problem, you've solved ones like this. So I just need to get the exponential value by itself. So I need to divide by 1,000, which means I'm left with 1/2, or I'm going to write it as 0.5. And that's 0.965. to the x. Now, in order to bring that x down, remember using those properties we did yesterday, I can either use natural log or just regular log. I'm just going to use natural log. It doesn't matter. Natural log of 0.5 and then natural log of 0.965 x. Remember, the reason I do that, because now with the properties that I have, I can bring this x value down in front, so that this comes down to natural log 0.5 which is perfect, because now I can simply just divide natural log of 0.965. And I will do that. Can I move down? Can I move down? New sheet. Okay, so then I'll just take natural log and then the natural log of 0.965. And that's going to be my x value, the number of minutes it's going to be for the half-life. Okay, so if I go, so let me punch into my calculator, whether you're using the TI that's for the MCA or this one or some other, or your own calculator, it's fine. So I'll go natural log 0.5 and then natural log 0.965. Oop, that's a 2. I'll get that. And remember, just so that we're on the same page, you can do this with log and get the exact same thing. I'm going to just round to, I don't know, the nearest hundredth would be fine, and we'll be close enough. So that means that my half-life, in this case, is 19 point, let's go 46. So that's about, and that's minutes. Okay, so and in general, when I look at something like this at the beginning, if I have an equation where I'm just looking for this exponent value, more often than not, what you're going to end up dealing with is adding that log or natural log to both sides, because you're trying to bring down and isolate that x at the end, which is an easy way to use your log properties to be able to do that. So that's pretty common when you have that. Okay. All right, let's step our game up here a little bit. If you want, go ahead and pause the video and I'll see if you can get your properties down and manipulate your equation and figure out what x is, which is give the total sales X days after release. see if you can do that. Otherwise, if you want, I'll give you at least the first setup and give you another opportunity to solve from there. So pause the video if you want to start now. Otherwise, I'll be doing this first little step to help you out. Okay, so if you're struggling, or if you're looking at this and you're saying, I have no idea where to start, I need to obviously isolate x, and the problem is that x is on the bottom of this fraction. So I need to bring that whole thing up, which I can do. I can move this whole thing by simply just multiplying by all of that to both sides. Okay, and this f of x, the solution, the end result will be 6,000. So let's just write everything equals 12,000. 1 plus 499. Negative x there. If I just take this whole thing, that whole bottom piece, and multiply that to both sides, I've now gotten it out of the denominator, which the important part is getting the variable out. So I can do that. So now I'm going to put this in some brackets so you can see this. 1 plus 499. This step is probably the part that if people are stuck, that's where they get stuck at. 12,000 to 3. Okay. Now I just go through the process of getting x isolated, or the exponential value of this part. So I divide by 6,000. So now I'm left with 499, 1.09, negative x 2. Okay, subtract 1, and then I'll just do everything kind of both these steps. Minus 1 and then divide by 499. I'm going to keep this as a fraction just because it's not nice, and I'm not going to round for that. 1.09 x, and then this would be 1 over 499. Now that I'm here, again, like the last one, because I want to bring this x down, log or natural log to both sides is where you're going to go. Okay, so you have that. I'm going to go to the next screen so I just have some more space. Okay, so that means if I do that, I'd go, again, oh, well, doesn't matter. I'll just go log of 1.09. Gosh, that's ugly. 1.09 inverse x equals log 1 over, what was it? 499. Okay. So again, the whole point is that bringing that down, doesn't matter if it's negative or positive, I'm going to bring that whole negative x down. So now I have the negative x log 1.09, which is what I wanted. 499. Now I can just divide. So now I have inverse x, or negative x, equals log 1 over 499. This is a prime example of keeping your work organized to kind of see what you're actually dividing by. Okay, so then I'd go to, oops, wrong one. Sorry about that. So now I just go log or natural log. Again, it doesn't matter which one you did it with. So I'd go log of 1.09. Oops, delete. Let's just clear everything. Log, if I'm going to start, it'd be 1. And then I'll divide that by log of 0.09. There we go. Don't be worried about the negative. It should make sense because I have a negative exponent. So this is all going to turn positive at the end here. So if I have negative x equal to, let's just round it to negative 72.09. Hopefully it makes sense that x would equal 72.09. And we call that days for us. Okay. There you go. So, and there's an easy way to check this if you're not 100% sure, is you can just simply plug that 72.09 into your original equation where it was the f of x, f of x equals 12,000, blah, 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 blah. And if you plug the negative, or the 72.09, in this case it'd be negative 72.09 as the exponent you'd be using, you should get right around 6,000. And it'd be a little off because you rounded, obviously, but you can double check that. Okay, and we'll do that with the next one here for sure. But there's your value there. Okay. All right. So let's see if we can go from start to finish here. Now we're dealing with some different properties because we're already starting with a log. So if you want to take a second, pause the video, check some of those other properties that we used yesterday. That would probably be very helpful. But if you want to try and set that up or go as far as you can, pause the video, and when you're ready to roll, we'll get ourselves going. Okay. So it should make sense that D here is our 107. That's the decibels that we're dealing with. So 107 is 10 log, and then we'll get this I 10 to the negative 16. Now, in my case, when I'm looking at this, if I see log with the quotient, I'm going to be splitting that up into subtraction. So just kind of keep that in mind as we start. That should be kind of in the back of your head that you're going to end up splitting this up. So let's get the log by itself, divide by 10. So I got 10.7, and now I get just that log by itself. I 10 to the negative 16. Like I said, because this is as a quotient, I can split this. Let's see if this helps us. Log I log 10 negative 16. Okay, if somebody gets stuck or you said, I don't know, oops, that's not an equal sign. Sorry about that. Should be a minus. People get stuck, this would be kind of the first place if you're still not 100% sure. This is what we can manipulate now. Because, again, this is using our properties that we had. If I change my color just so you can see, where if I have log base A x equals y, I can change that to, let me move this over. If I have that, I can change that to the base. We'll make that A, and then I go log AX, because that's also equal to, well, then I can do that to the other side where I would go either way. But the big piece on this is that this basically all goes away, and then all I'm left with is the X. So that's the big part, is I can just simply, because I know this, and hopefully you can see, because this is log 10, that means the base is 10. Because I got that, I can simply just say that everything, that whole thing is equal to negative 16. So if that's confusing at all, or if you don't remember that, I'd go back to the videos from day 1 and day 2 for the basic properties to show that. So that means now I can go 10.7, where am I at, log I, minus, and again, because we can bring that all the way down, negative 16, okay, which will change to, obviously, plus. So now I'm going to change my, so I got more space. So now we're here. So now I got 10.7 log I plus 16. Now it looks pretty easy as far as what the next steps are. Minus 16, so then I would get negative 5.3 log I. And I'm going to flip-flop this just so that we can kind of see it in a little, we've kind of used it in our other ways, because this is pretty much solved. If you can't see it yet, I'll show you. So we got it here. I can convert this into a exponent value here. So I can say the base 10, negative 5.3 is equal to I. This value is my intensity. Okay. And again, I can test this and see if that actually works. So if you go through the whole thing and say, like, that doesn't really make sense, or I'm not 100%, plug it back into your original equation, which was this. So if I plug in 10 to the negative 5.3 for I should get, for the decibel, I should get right around 107. Well, in this case, I should get right exactly 107. So let's see if I do that. Let's see if that gives me what I want. See if I can do this one time through here. So let's go 10. Let's go log parentheses. I'm going to have to use a couple parentheses. Let's go 10 to the, you use your negative and not minus. That's usually that caused me problems the first time I got something weird. Divided by 10 to the negative 16. That should be it. There's my 107. Okay, so that's an easy way to check. And the way that I knew the first time that I didn't do this right is I did not get 107, but that's an easy way to say, I don't know if I got this right, or can you check for me? Plug it back in and see, especially for these ones. You should get what you're trying to get for your output. That should be what you get there, okay? All right. One more on this thing kind of set up as this last one. So here's another situation, talking about the learning curve. Here's our equation. So why don't you go ahead. We're trying to get 47 lessons is what we got. We're trying to figure out the words per minute. Plug it in, work your way through, see if you can figure out what n is going to be. Okay, let's see how you did. Okay, so for this last one, obviously we're going to write, oops, not in a highlighter. So we got 47, negative 144, number 90 here. Okay. So now, again, I'm trying to get log by itself. So divide. I'm going to leave this as a fraction just because it's not all that pretty when I'm dealing with it. 144. So now I'm left with log 1 minus n 90. Again, if people are getting stuck, this is usually the place that this happens. But again, just like the last one, we're going to use the same kind of principle where we're going to convert this using our base and convert this into an exponential, which means both sides need to get it. So 10, negative 144 equals, again, 10, but then all of this, which is log, and then 1 minus n 90. That's all in the exponent. Okay, and again, the reason I did that is because then I can get rid of this part. Right, all I'm left with then is this, which is super helpful for me because now that's a place I can solve. Okay, so I'm gonna go to the next page and get that, but we're gonna get rid of this. So now we're simply just left with 10, and then that's 47. That's an exponent, sorry, and then 1 minus n 90. Okay. Go through that process. I'm not going to solve this yet as far as the 10 to the 47 over negative 144 because it's going to give me something funky. So I'm going to keep all that in there till the very end. So minus 1. So I got 10, make a better exponent here, negative 144 minus 1, okay, equals negative n to the 90. Times by 10 times by negative 90. Everything's getting times by negative 90, which means the end result, negative 90. I'll bracket this. 10, 47, negative 144, minus 1. And that's going to give me my n value, or my words per minute that I would do. And this is what I'm looking for. So that's what I'll punch in. Again, the whole reason why I'm using that property. And again, if you're not comfortable with that property, go back to the previous videos. It'll give you that or extra practice for that piece. I need to get this base changed so this can go away. Okay, I'm converting those into exponents so then I can get rid of the log. And then I'm sitting with something a lot more comfortable that I can deal with here. Okay, so let's put that in. So I get negative 90 times 10 to the 47 divided by negative 144 and minus 1. See if it goes with it. There we go. I'm just going to round to, let's go to the 100th just to leave it there. Okay, so I know my n, or my words per minute, is right about 47 and a half. We'll go 47.55. We'll label it words per minute. Okay, again, if I want to say, well, I think that's right, but I don't know how. I don't know if I'm right or not. Plug that 47.55 in for n. And you should get, when you plug all that into that, you should get right around 47, which you will if you put that in there. Okay? All right. That's it for now. The next video I'll have in the help section, I'll get some extra help problems if you're just still kind of shaky on it, or you just want to see a couple more just to be 100% on that. You can glance down to the video for extra help. Otherwise, have a great day, guys, and let us know if you have any questions.